Introduction. Get ready, students. Today we will learn conic sections. Have you ever seen the wheel? What kind of shape it has? Yes, it is circular in shape. How many of you have dish TV at your home? And do you know what kind of shape it has? Yes, it is parabolic shape. Do you know what kind of path Earth follows while revolving around the sun? Yes, it is elliptical in shape. So finally, who will tell me what kind of shape this object has? It has hyperbolic shape. In this lesson, you will learn how to analyze these shapes and what role they have played in designing various objects. Objectives. At the end of this lesson, you will be able to find the equation of the circle which passes through certain points with given center. Find the equation of parabola with the help of given parameters and locate the coordinates of its focus and axis. Find the equation of the ellipse with the help of given parameters. Find the equation of the hyperbola with the help of given parameters. Sections of a cone. Conic section is the curve obtained when a conical surface is intersected by a plane. We know that a cone is the surface or the solid figure formed by moving a line so that the line always intersects a plane called the directrix and passes through a fixed point called the vertex. Now, we will discuss various sections of a right circular cone. Section of a right circular cone by a plane, which is parallel to its base, is called a circle. Section of a right circular cone by a plane which is parallel to a generator of the cone is called a parabola. Section of a right circular cone by a plane which is not parallel to any generator and neither parallel nor perpendicular to the axis of the cone is called an ellipse. Section of a right circular cone by a plane which is parallel to the axis of the cone is called hyperbola. Circle. A circle is the set of all points in a plane that are equidistant from a fixed point in the plane. The distance from the center of a circle to a point on the circle is called radius. The equation for the circle can be written as where CHK is the center of the circle, R is the radius of the circle, AXY is point on the circle. Example. Find the equation of the circle with center 3, 2 and radius 7. Solution. We are given the center of the circle, which is 3, 2 and the radius is equal to 7. The equation of a circle with center HK and radius R is given as x minus h whole square plus y minus k whole square is equal to r square. H and k is equal to 3 and 2 and radius r is equal to 7. After putting the values of center and radius, we get x minus 3 whole square plus y minus 2 whole square is equal to 7 square. By calculating it, we get x square plus y square minus 6x minus 4y is equal to 36. Parabola. A plane curve formed by the intersection of a right circular cone and a plane parallel to an element of the cone or by the locus of points equidistant from a fixed line and a fixed point not on the line. The fixed line is called the directrix. The fixed point is called the focus. A line through the focus and perpendicular to the directrix is called the axis of the parabola. The point of the intersection of parabola with the axis is called the vertex of the parabola. Standard equations of parabola. Let the vertex is at the origin and the axis of symmetry is along the x-axis or y-axis. Then 4 possible orientations are: equation of the parabola, y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4ay, x square is equal to minus 4ay. Let us rectum of a parabola is a line segment perpendicular to the axis of the parabola through the focus and whose end points lie on the parabola. The length of the latus rectum of the parabola, y square is equal to 4ax, is 4a. Example: find the equation of the parabola whose latus rectum is 4 units, whose axis is the line 3x plus 4y minus 4 is equal to 0, and the tangent at its vertex is the line 4x minus 3y plus 7 is equal to 0. Solution: let pxy be any point on the parabola, drawn Pn perpendicular to its axis and Pm perpendicular to the tangent at the vertex. Then Pn square is equal to latus rectum into Pm. That is equation 1. Now, Pn is equal to length of perpendicular from Pxy on the axis 3x plus 4y minus 4 is equal to 0. 3x plus 4y minus 4 upon under root 9 plus 16 is equal to 3x plus 4y minus 4 upon 5. Pm is equal to length of the perpendicular from Pxy on the tangent at vertex A. 4x minus 3y plus 7 is equal to 0. 4x minus 3y plus 7 upon under root 16 plus 9 is equal to 4x minus 3y plus 7 upon 5. Latus rectum is equal to 4. From equation 1, 3x plus 4y minus 4 upon 5 whole square is equal to 4 into 4x minus 3y plus 7 upon 5. 3x plus 4y minus 4 whole square is equal to 20 into 4x minus 3y plus 7. This is the required equation of the parabola. Ellipse. An ellipse is the set of all points in a plane, the sum of whose distance from two fixed points in the plane is a constant. The two fixed points are called focus of the ellipse. The midpoint of the line segment joining the focus is called the center of the ellipse. The line segment through the foci of the ellipse is called the major axis. Its length is 2a. The line segment through the center and perpendicular to the major axis is called the minor axis. Its length is 2b. The endpoints of the major axis are called the vertices of the ellipse. The distance between the focus is denoted by 2c. The eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse. That is, E is equal to C upon A. Standard equations of ellipse. Let the center of ellipse is at origin and its focus are on x-axis or at y-axis. Two such orientations are x square upon a square plus y square upon b square is equal to 1. X square upon b square plus y square upon a square is equal to 1. The length of the latus rectum of ellipse x square upon a square plus y square upon b square is equal to 1 is 2b square upon a. Example: find the eccentricity of the ellipse if the distance between the foci is equal to the length of the latus rectum. Solution: distance between the foci is equal to length of the latus rectum. 2AE is equal to 2B square upon A, or AE is equal to A square into 1 minus E square upon A, or E is equal to 1 minus E square, or E square plus E minus 1 is equal to 0. E is equal to minus 1 plus minus under root 1 plus 4 upon 2, which is equal to minus 1 plus or minus under root 5 upon 2. For an ellipse, 0 is less than e is less than 1. Rejecting e is equal to minus 1 minus under root 5 upon 2, which is less than 0. We have e is equal to under root 5 minus 1 upon 2. Hyperbola. A hyperbola is the set of all points in a plane, the difference of whose distance from two fixed points in the plane is a constant. The two fixed points are called the focus of the hyperbola. The midpoint of the line segment joining the focus is called the center of the hyperbola. The line through the foci is called the transverse axis. Its length is 2a. The line through the center and perpendicular to the transverse axis is called the conjugate axis. Its length is 2b. The points at which the hyperbola intersects the transverse axis are called the vertices of the hyperbola. The distance between the two focuses is denoted by 2c. The eccentricity of an hyperbola is the ratio of the distances from the center of the hyperbola to one of the foci and to one of the vertices of the hyperbola. That is, E is equal to c by a. Since c is greater than or equal to a, the eccentricity is never less than 1. Standard equations of hyperbola. Let the center of hyperbola is at origin and its focus are on x-axis or at y-axis. Two such orientations are x square upon a square minus y square upon b square is equal to 1. Y square upon a square minus x square upon b square is equal to 1. The length of the lattice rectum of hyperbola is 2b square upon a. Example. Find the equation of the hyperbola if the length of conjugate axis is 5 and the distance between its foci is 13. Solution. Let the equation of the hyperbola be x square upon a square minus y square upon b square is equal to 1. Conjugate axis is equal to 2b is equal to 5. b is equal to 5 by 2. Distance between the foci is equal to 2ae is equal to 13. ae is equal to 13 by 2. Now, b square is equal to a square into e square minus 1. A square plus b square is equal to a square e square. A square plus 5 by 2 whole square is equal to 13 by 2 whole square. A square is equal to 13 by 2 whole square minus 5 by 2 whole square is equal to 36. The equation of the hyperbola is x square by 36 minus y square by 25 by 4 is equal to 1. That is, x square by 36 minus 4y square by 25 is equal to 1. Did you know? Euclid was a Greek mathematician often referred to as father of geometry. His treatises are one of the most effective work in the history of mathematics used for teaching mathematics. René Descartes gave an important contribution in field of geometry. He develops the analytical geometry. Summary. Let us summarize what we have learned. A circle is the set of all points in a plane that are equidistant from a fixed point in the plane. The equation of a circle with center hk and radius r is x minus h whole square plus y minus k whole square is equal to r square. A parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point in the plane. The equation of the parabola with focus at a0, where a is greater than 0, and directrix x is equal to minus a is y square is equal to 4ax. Latus rectum of a parabola is a line segment perpendicular to the axis of the parabola through the focus and whose end points lie on the hyperbola. Length of a latus rectum of a parabola y square is equal to 4ax is 4a. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in a plane is a constant. The equations of an ellipse with foci on the x-axis is x square upon a square plus y square upon b square is equal to 1. Latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci and whose endpoints lie on the ellipse. Length of a latus rectum of the ellipse x square by a square plus y square by b square is equal to 1 is 2b square by a. A hyperbola is the set of all points in a plane, the difference of whose distance from two fixed points in the plane is a constant. The equation of a hyperbola with foci on the x-axis is x square by a square minus y square by b square is equal to 1. Latus rectum of hyperbola is a line segment perpendicular to the transverse axis through any of the foci and whose endpoints lie on the hyperbola. Length of the latus rectum of the hyperbola x square by a square minus y square by b square is equal to 1 is 2b square by a.